Hey guys, welcome to the 77th C programming tutorial, and in this tutorial we're going to be timing how long it takes our program to execute. And since we're dealing with time again, we need to go ahead up to the top right here and just include time.h. So the next thing that we're going to do is just go ahead and write a very small program that we're going to record. So we're just going to write a loop that's just going to iterate 10 million times. So we're going to say for int I is 0 while I is less than 10 million, and then I++. And the reason that I need to make this so big is if I were to make this like 100 or 10 or something, then when we outputted the time onto our screen, it would just be so small that it would just output 0. So if we make this like 10 million or something, then we'll actually be able to see a value. And the next thing that we're going to do is just go ahead and call a function called clock. And this clock function will simply return the number of ticks that have elapsed since our program started executing. And we're just going to go ahead and store this return value in an integer variable, and I'll just call it ticks. And then we'll just go ahead and output this ticks value onto the screen. So we'll say printf mod I and then just ticks. So when we run this, out onto our screen we just get 23. And you're probably thinking, 23, great, what does that even mean? 23 ticks. Well, thankfully there is this constant called clocks per second. And basically this constant right here will just tell us how many ticks are per second. So if we just divide ticks by the number of ticks in a second, then that will just give us the number of seconds that have elapsed since our program started executing. And then we'll just go ahead and cast this as a float so that we can actually see a value. So again, if I didn't cast this as a float right here, it would just return a whole value like a 1 or a 2. And since our program isn't going to take a whole second to execute, we need to cast this as a float so we can actually see it represented as a decimal. So we'll see like 0.02 seconds or something like that. Alright, and then I just need to make this mod f so it prints out a float. So when I run this, we get out onto our screen 0.023, so on. Alright, so this just tells us how long it took our program to execute. And you're probably wondering why these two values are different. So CodeBlock's execution time is 0.044 and ours is just 0.023. Why are they so different? Well, our value right here doesn't include the time it took to actually print it out onto the screen and the program teardown. Theirs, however, does. So right here when we call clock, that is what we're actually recording. We're recording the number of ticks from the program setup, this for loop right here, and that's it. However, CodeBlock's time actually counts this, and the teardown as well. Alright, so that's just the reason why they're so different. And if we were to mess with this value right here, like if I were to increase this value, so if I made it the maximum value for an int, like 0x7ff, this is just the maximum value for an int, so the largest possible value when I run this, then it's actually going to take some time for a program to execute. I think it's like 4.9 seconds or something like that. Yeah, 4.973. And the other thing you're probably wondering is, why am I even teaching this if CodeBlocks just outputs this right here? Well, if you're using a different compiler, like if you're using Visual Studio or if you're just compiling it with GCC and then running it in a terminal window, then you won't get this nice output that CodeBlocks provides for us. So if I were to just go ahead and run our program in a terminal window, or actually a command prompt, we're not on Linux. So if I run this in a command prompt, then we're not going to get that really nice output that CodeBlocks gives us. And I made this such a large value that it's going to take some time to execute. But yeah, right here, this just told us now the amount of time that it took our program to execute, and since we're not in CodeBlocks anymore, we obviously don't get that nice CodeBlocks output. Alright, so that's pretty much it for this tutorial, so see you guys.